All right, ladies and gentlemen, let's do this problem here. In science class, Antonio and Anna were using a science probe. Yes. Rules. In science class, Antonio and Anna were using a science probe attached to a laptop to measure the speed of a marble as it exits from an 8-foot-long ramp. To double-check the speed, they measured a section of the floor that was 12.5 feet in length and used a stopwatch to mark the time each marble took to travel that distance. Antonio and Anna discovered that it took 2.1 seconds for a marble to travel 12.5 feet. They used the formula r is equal to dt to determine their calculation, where distance d was measured in feet. This is what makes math so incredible, you all, is that other people have invented formulas to make our math easier. And the time t was measured in seconds. What was the constant rate of change that the marble traveled in feet per second to the nearest hundredth? 5.95 feet, 9.76 feet, 16.80 feet, 26.25 feet. Okay, so when it asks us to use the distance formula, we're going to go back here to our formulas, and we're going to find the distance formula. So what I want you all to do going forward is I want you all to go back, find the formula, okay, box it, and then put the number that's for. Okay, this is for number 8, and then circle the formula. Okay, we're going to start doing this going forward, so y'all get more used to using the your strategies. All right, so the distance equals the rate multiplied by the time. Okay, distance equals the rate multiplied by the time. So now we're back. So we know, after we read the question and the options, we're going to underline the question specifically. What was the constant rate of change that the marble traveled in feet per second to the nearest hundredth? Okay? We underline the question. Now we're going to label and annotate. Okay? We're going to box key terms, and we're going to circle our numbers. Now, this is an 8-foot-long ramp. Now, all this is telling us, ladies and gentlemen, is how long the ramp is, okay? That just tells us how long the ramp is. So you can underline it, but it's not key information. To double-check the speed, they measured a section of the floor that was 12.5 feet in length. So this is what they measured, okay? And used a stopwatch to mark the time each marble took to travel that distance, okay? And they used a stopwatch to mark the time each marble took to travel that distance. So the distance really is 12.5, okay? So 12.5 feet, this is D, which is our distance, okay? This is our distance, 12.5 feet. All right? And use a stopwatch to mark the time each marble took to travel that distance. Antonio and Anna discovered that it took 2.1 seconds, okay? So we're going to circle 2.1 seconds. And this, as you might have imagined, is our time, T, 2.1 seconds, all right? For the marble to travel 12.5 feet, which we already indicated, is our distance. They use the formula, this is the distance formula, the rate equals d divided by t. Now, the constant rate of change, this is r, which is the rate of change. Okay, this is what makes it so beautiful, ladies and gentlemen. This is the beauty of the art of mathematics. When we use our rule strategies and we label We can decipher the code. It's a code, ladies and gentlemen. And the secret is the knowledge of being able to use these methods to decipher the code. The complexity is the beauty of it, and our intelligence as human beings, that's what makes us different. That's what makes us unique in our universe, is that we can solve things like this. So this is what makes it so much fun. So the rate is equal to the distance divided by the time. So the rate's going to be the distance, which is 12.5 feet, divided by the time, which is 2.1 seconds. Whenever you see this fraction or this division symbol, this means that we're going to look for a quotient. The rate of change is going to be our quotient. So we're going to divide 12.5. So we're going to divide 12.5 feet divided by 2.1 seconds. So how many times is 2.1 going to 12.5, ladies and gentlemen? Let's add 2.1, 2.1, 2.1, 2.1. That's going to be 2, 4, 6, 8, 10. If we added another one, our decimal value would be too big. So let's just add 5 of these. Okay? That's going to be 5.2, 4, 6, 8, 10, 10.5. So we're going to do 10.5. All right? Subtract this out. 5 minus 5 is 0. 2 minus 0 is 2. 1 minus 1 is 0. Now we're going to bring our decimal value down here. So now we'll bring a decimal value up here. Okay? 2.1 goes into 12 5 times. Now I'll rewrite the feet over here to give us some space so we can add our zeros. If we add 2 zeros, let's bring a 0 down here. 0.2. We'll bring a 0 down here. Okay, so how many times is 2.1 going to 2.0? Well, 2.1 goes into 2.0. It's saying 0.95 times. Let's see if that's true. 2.1 multiplied by 9.5, and I'll put the point here. 5 times 1 is 5. 5 times 2 is 10. Put a 0 for the hundredths place. 9 times 1 is 9. 9 times 2 is 18. All right. All right, there we go. Now, 5 plus 0 is 5. 0 plus 9 is 9. 1 plus 8 is 9. Bring down our 1. Now, how many digits do we have, ladies and gentlemen, to the right of the decimal place? 1, 2, 3, 3. So we're going to move, and these look like butt cheeks, so we can call them butt cheeks so we remember. We're going to move these towards the left. 1, 2, 3. Okay? So this is going to actually round up, but this is going to be equal to 1.995, which rounds up. This rounds up to a 10. This rounds up to a 10. We can push this to 2. So this is approximately 2. Okay? That's the reason why it's 5.95, which is our closest possible answer. 9.76 is too big. If this is too big, these are also going to be too big. Okay? So our answer, ladies and gentlemen, is 5.95 feet per second. So this person here is not accurate. And based on their process, they did divide here. 8 divided by into 14.5. See, they were looking at 8. Don't let them confuse you all. The only part that we're measuring is when the marble goes from the ramp, and then there's a distance that it goes. See, so this is the picture right here. All right? Here's the ramp. And then the distance that they're measuring is once the marble gets off the ramp and goes a certain distance this way. Okay? This is the 12.5 feet, okay? From the moment the marble leaves the ramp to the moment it goes, it's the full 12.5 feet. The time it takes is 2.1 seconds to do so. Don't worry about the 8-foot ramp, okay? This is the 8-foot ramp. But as it says here, if y'all have to slow down and read, it says here, Anna Antonio, okay, we're using a science probe attached to a laptop to measure the speed of a marble as it exits, okay, as it exits, it's a key word there, from an 8-foot long ramp. To double check the speed, they measured a section of the floor that was 12.5 feet in length and used a stopwatch to mark the time each marble took to travel that distance. So it's traveling the 12.5 feet after it exits the ramp, okay? So this is after exiting the ramp. All right? So the answer, ladies and gentlemen, is A. We divide 12.5 feet by 2.1 seconds. Okay? All right, so this is going to be a weak concept and process. All right? Not accurate. Thank you, and I hope that this helps y'all solve problems like these. Ask me any questions that y'all have.